Chapter 4, Section 16, Advanced Method for Univariate Outlier Detection. Part 1. As advanced method for univariate outlier detection, this course covers 4 methods: trimmed mean, median and MAD, robust z-score, and winsorization. This section covers the first 2, trimmed mean and median and MAD. Robust z-score and winsorization will be covered in the next section. The first method we introduce here is based on standard deviation method, but uses trimmed mean instead of arithmetic mean. Trimmed mean is an average calculated by excluding a certain percentage of the top and bottom data. This reduces the impact of extreme outliers. For example, using a 10% trimmed mean, we cut off 10% of all data, makes it less likely that extreme outliers will affect the mean and standard deviation. To calculate the trimmed mean, first, we sort the data in ascending order. Then, remove a specified percentage, for example, 10% of the smallest and the largest values. Then, by computing the mean of the remaining values, we can obtain the trimmed mean. Now, let's run the outlier detection in Python. Select 4 columns from the data frame used in the previous section: the original values, the detection results from the z-score method, the detection results from the IQR method, and the detection results from the iterative method. Using these 4 columns, create a new data frame, df. We will also use this data frame to compare the results of each detection method. Outlier detection using trimmed mean can be performed with this code. Let's look at the first half. We import the trim mean function from the scipystat library. In step 1, we use the trim mean function to compute the trim mean of the column value of df. The proportion to cut equals 0.1 specifies that we exclude the top and bottom 10% of the data. In step 2, we exclude the top and bottom 10% of the data and extract only the middle 80%. The first row calculates the value for the bottom 10%. The second row calculates the value for the top 10%. To apply the upper and the lower conditions simultaneously, join the first and the second row with ampersand. Next, let's look at the second half of the process. In step 3, we calculate the standard deviation using the trimmed data. In step 4, set the lower and upper bounds as criteria for outliers as trim mean plus minus 3 times trim standard deviation. In step 5, identify outliers based on the criteria and create a new column, outlier underscore trim. The vertical bar represents a logical OR and marks any data as outlier if the data satisfied either condition. The left side of the vertical bar in parentheses represent the values less than the lower bound, and the right side represent the values greater than the upper bound. Let's display the data frame. You can see that the data point with the largest value is detected as an outlier when using the trimmed mean. This is a slight improvement over the ordinary z-score method, which did not detect outliers. However, data points with small values were not detected as outliers. This is due to the fact that only one of these was excluded when calculating the trimmed mean, even though there was not much difference in the values of the 2 data points with the smallest values. The result depends on the percentage of data points excluded in calculating the trimmed mean. The second method is to use the median and the median absolute deviation, MAD for short, instead of the standard deviation. MAD is the median of the absolute deviation of data points from the dataset's median and can be computed by this formula. Because the median is less susceptible to outliers, this method allows for robust outlier detection with less distortion from outliers. The lower and upper bounds as the criteria for outliers are computed as the median plus or minus k times MAD. Usually, the value of k is set to 3. Let's implement the method using median and MAD in Python. First, use the pandas median function to compute the median of the data. Next, we compute the MAD. We can compute MAD by taking the absolute value of each data point minus the median, and then computing the median among them. Next, set the threshold to identify outliers. K is usually set to 3, but it can be adjusted to an appropriate value depending on the data. Then, calculate the lower and upper bounds of outliers. These are defined as the median plus minus k times the MAD. Finally, the outliers are stored in the new column named outlier underscore MAD. Here, if the value is less than the lower bound or greater than the upper bound, it is true and stored in the new column outlier underscore MAD. Let's see the results. This method detected some data points with large values as outliers, but did not regard data points with small values as outliers. This may be due to the fact that the method is based on absolute values. Based on absolute values, data points with large values are more deviated from the median. Therefore, we can say that the data points with large values were more likely to be regarded as outliers based on absolute value. In the next section, we will explain robust z-score and winsorization. Thank you for watching. If you have any questions, feel free to ask in the comments. Your feedback is always appreciated.